Okay, let's make artificial intelligence easy. So, first and foremost, there is no artificial intelligence without machine learning. So, in order for us to explain what machine learning is, we have to explain what a model is. So, machine learning is I can say, the art or a technique of training a model to be more and more intelligent. That's about it. Intelligent just means it's logical in what it's supposed to do, like large language models that are used in ChatGPT and Claude AI to answer questions accurately. So sharp. Let's talk about a model. What is a model? A model, it's simply a number of weights and biases. These are just numbers, floating point numbers. Floating point just means it has a decimal and goes exponentially so. So you have your input, you multiply it by a weight, you plus a bias. So you remember that equation, y is equals to mx plus c. Here it is again in artificial intelligence. So you have y is equals to m, which we call the gradient, and then x is a variable, and then plus c, the c is a constant, that's the bias. You see this thing. So the m is going to be the weight that we're going to train. That's the machine learning step. So we train, by the way, it's random. We just take a random number, we multiply it by some input. Let's say you say drinking water is 0.5. If drinking water is 0.5, our x is going to be 0.5. You multiply by a random number, that gradient m, and then that gradient we call a weight in machine learning and AI terms. So we just, if we drink water, enough water, and then we multiply it by a certain weight, and we get good results. Let's say at the end of the day, you have more energy, then you're going to keep that weight because that weight maximizes your input. You see this thing? Yes. So in machine learning, we say this is the amount of water that I drank, and if I multiply it by a certain weight and I plus it with a certain bias, this is the result, the expected result that I need to get. That expected result, by the way, is called a label. It's called a label. So you say today 4 liters of water, which is a lot. 4 liters of water multiplied by 0.6, which is the weight, plus 0.3. By the way, that 4 liters, we have to always get it to be one, between 0 and 1. So less than 1, more than or equal to 0, or both inclusive. See this thing? Yeah. So that's how we're going to train our model. We train our model. It's literally random numbers. So y equals to m, which is a random number that we're going to change each and every time, and then x, which is our input. For example, as I mentioned, the amount of water that you drank that day. You see this thing, and then you say today, if x is 0.5, half a liter of water, and then some other at the end of the day I get very dehydrated, I'm going to make that function to return a value that shows dehydration. But if I get it to 4 liters of water, then obviously standardize it to between 0 and 1, and get the results that I got in real life. Get the y value, the label to be the same as hydration. Then I'm going to keep those weights. But if I don't get the results, the right results, if 0 equals dehydration and 1 equals to hydration, and I enter a certain value for M and a certain value for C, and they don't equal, they don't match what I'm expecting, then I'm going to keep on modifying these weights and biases, mainly weights. We train weights. So we start with random numbers. And if we get closer, this is where it gets quite nice. If it gets closer to what I'm expecting, I try to modify it less. So I modify it in less amounts. We call it a learning rate when you're modifying it with less offsets. You see this thing. Mara, we'll talk about these in simpler terms. Ask questions. Ask questions. I'll be mentioning examples. For example, supervised learning, unsupervised learning, reinforcement learning, and how LLMs actually operate. And yeah, we'll talk about these. Let's understand these things. Let's make them as simple as possible. Let's go.